We're going to be starting with direct variation. Direct variation is a good starting point when we're talking about different types of variation. Direct variation is a function with the formula in the form of y equals k times x to the power of n, where k cannot equal 0 and n has to be greater than 0. Now, when we're looking at this direct variation equation, notice there is nothing added or subtracted off of that x spot. So, for instance, if we were to look at y equals 2x, or if we had y equals 3x squared plus 6, or y equals 5x cubed. Now, one of these does not belong. And I say that because it is not actually a direct variation. So when we have our x, it doesn't matter what the exponent is, so long as it's greater than 0. When we're looking at that, the left, the middle, and the right both have exponents that are greater than 0. We have 1, 2, and 3. So that's not what's going to limit us here. But this one right here has a plus 6. Because it has that plus 6, this is not actually a direct variation equation. So don't think that just because it's got an exponent means that it is not a direct variation equation, because it still is. The other thing to note when we're looking at direct variation, the k value, this is what we call a constant of variation. This just tells us what number we're multiplying by. With that, there will be times when you will be asked to write a direct variation equation based on a situation, and then you might be asked to solve for it. So, for instance, it might be in the form of y is directly proportional to x to the power of 4. If y equals negative 13,824, when x equals 12, we want to find y when x equals 6. Okay, so right there, they give you some numbers and a situation in order to figure out what the k value is. So the first thing we look for when we're looking about direct variation, directly proportional to x to the power of 4. So that means we have y equals k times x to the power of 4. That's just based on the first sentence. Now we look at the second sentence and look specifically at the numbers that they give us. They tell us where the y and the x values go in order to figure out our k. So we have 13,824 equals k times 12 to the power of 4. So now based on this, this is just like any old algebra problem in which you need to solve for k. Now, I'm going to go ahead and simplify this and get my 12 to the power of 4 going. So we have 13,824 equals k times 20,736. Based on algebra, we're going to divide by that in order to get the k value. So our k value here is going to be 2/3. So k is a fraction, yes, but it doesn't change much for what we're trying to do. So now that we've got that, we are going to look at Find y when x equals 6. So we've got this equation. You could just keep going down in your notes if you want. I'm just going to go off to the side so we can have everything all in one spot. So this is our direct variation equation now that we have solved for the k. Now we're going to plug in 6 into the x spot in order to calculate the y. And this is just something that you can plug right into your calculator. You don't need to show me step by step what you're doing. I kind of have an idea of what you're going to be doing there. So looking at this then, y equals 864. So the key is it's going to be set up, like I said, they're going to give you that first portion to give you in the green there, they're going to give you that information in order to set up your direct variation equation. Be cautious about what it's saying with like the x to the fourth. It might not actually give you x to the fourth. It might say the cube of x. So you need to know that that's x cubed. Certain things like that. In the blue then we get numbers to plug in to solve for k. Then once we get our k value, like the purple there, you then plug in your x value to get your final answer. So it's a lot of manipulation in order to get to the final product. You will also have an opportunity to look at the story problems in those situations. And last but not least, I need to talk to you quickly about the graphs of direct variation. Actually, I take that back. That will be for day 2.